Hi friends, welcome to Talent Sprint's Banker's Choice program. In this session, we are going to look at a very important topic called simplifications, which comes under the quantitative aptitude section of various bank exams. Especially in the SBI clerks exam, the weightage of simplifications is quite high, and we can expect about 10 to 15 questions from this topic alone in the SBI clerks exam. This topic is all about doing various arithmetic operations to get the required answer, right? Simply numbers with various arithmetic operations like additions, subtractions, multiplications and divisions is given. We are required to solve it in a step-by-step process and we should get the required answer. Before we start solving questions from this topic of simplifications, let us first understand the basic rule that we need to follow. And this is the order of operations. You know that in simplifications, we have to perform various arithmetic operations like additions, divisions, subtractions and multiplications. And when you solve a question based on simplification, there is a hierarchy that you need to follow, right? Which operation has to be done first, right? So let's understand the order of these operations that we need to stick to while solving questions from simplifications. Well, I'm sure all of you are aware of this order of operations as we have learned this in our school days, right? This is known as BODMAS, the rule of BODMAS, right? So let's understand what is this rule and how does it help us in solving questions from simplifications. Well, this is also known as PEDMAS or PIDMAS in various other parts of the world, but we in India call it as BODMAS rule. Now here, each letter stands for a word, and this will give you the hierarchy of operations that we need to follow. For example, B here stands for brackets. O stands for order of and exponential operations. D stands for division. M stands for multiplication. A stands for addition. And the last one here, S, stands for subtraction. So this is the order that we need to follow while solving a question from simplifications, right? The first one here is brackets. So this means that in a given question, if you find any part of the question within the brackets, that has to be simplified first, right? Brackets, or it is also known as parentheses, right? So the first step here is to simplify the bracketed part. Then once it is done, we move on to the operations of order, of, or these are nothing but the exponential operations, right? For example, sometimes we see 3 by 8 of, 4 by 5 of 16. So what does that of mean here? Of is nothing but multiplication, right? So we need to first simplify that of part. Or operations related to orders. Orders are nothing but powers. For example, in a given simplification question, we may have 3 squared. So that 3 squared has to be simplified first. We should take it as 9 before we proceed to the next step. Likewise, it may have something in square root of 3136. So before we look at the various steps of division, multiplication and so on, we first need to simplify the square root of 3136, right? So all these other operations comes under O, right? Exponential operations or indices, order, etc. Then once that is done, we move on to the basic arithmetic operations, divisions, multiplications, additions and subtractions. And in this, the first priority, the highest priority is given to division. Always remember, you need to simplify division first. Then we go for multiplication, followed by additions and subtractions. So this is the order that you need to stick to while solving questions from simplifications, right? I would like to repeat it once again. This is known as the BODMAS rule, right? Brackets, of, order, exponents, all those operations, then division, multiplication, addition and subtraction. If we do not follow this order, then we may get a wrong answer, right? So make sure that we stick to this while solving any question from simplification. So this is one of the basic rules of mathematics that we need to apply while answering any question from simplification. And I would say not only simplifications, you take up any topic from quantitative aptitude. For example, let's say there is a question on time and work, which involves some numerical calculation to be done. Even in that case, when you're simplifying that part, the simplification part, you need to follow this order, right? The BODMAS rule. Right? So this is not only useful in the topic of simplification alone, but in all the other topics of quantitative aptitude as well. And not only in mathematics. This is the rule which is followed in science, physics, technology, programming languages, everywhere. This is what is followed when we go for simplifications, right? So this is one of the fundamentals which I'm sure all of you are already aware of, but let's quickly get an idea on this. Like we have already understood what is BODMAS, what does it stand for, and while solving questions from the workbook, we'll look at how do we apply this. So let's get started with the session on simplifications. I'll try to take up as many questions as possible in this session, and for any doubts or clarifications, you can just get back to me through the live chat. Apart from the rule of BODMAS, there are various smart ways which can be applied for solving questions on simplifications. For example, there's one method called as units digit method, which is very, very useful in answering many questions from simplifications. Likewise, there is a concept of digital root digit, right? Even that will be useful while answering questions from simplifications. We will not have to simplify the complete question there, right? Just by applying a smart technique, we'll be able to find out the correct answer option. But we'll look at these techniques and methods while solving the questions itself, right? So let's get started with this topic on simplifications. We'll first start with some very basic questions on additions and subtractions, right? In SBI clerk's exam, out of 10-15 questions that you get on simplifications, there are very simple questions which just involves operations of additions and subtractions. So let's first look at some of the questions based on that, and then we'll move on to the other higher difficulty level models, right? So I would like to start with, I'll anyway put the question on the board here so that you don't find it difficult, right? The question here says it is 38.734 plus 8.638 minus 5.19 is equal to what? So very basic question which involves addition and subtraction. These are the two operations, right? And the given options here are 41.971, second option is 42.179, the third option here is 43.072, fourth one is 42.182, and the fifth option is none of these, right? So a simple question on simplifications with the 5 options given to you. Now, before I give you the solution, I would like all of you to quickly solve this and get me the right answer. You have 30 seconds. Your time starts now. All right, friends, I hope all of you have got the right answer by now. Let's look at the solution for this question. Now, how do we generally solve this, right? Going by the traditional method, you'll have to write the numbers one upon the other and then add them using the basic conventional addition and subtraction method, right? So let's follow the traditional method first, see what's the answer, and then we'll follow the smart way of getting the answer, which doesn't require you to write too much on paper, right? So let's first look at the traditional conventional way of getting the answer. What do we do? 38.734. Then we say the next number here is 8.638, and you know that when you are writing the numbers one upon the other, you have to write them properly. All the unit spaces have to come in one straight line. All the 10 spaces have to come in straight line, right? Or here in this case, we'll have to balance the decimal point there. So it's 8.638. So we properly write it as 8.638 minus 5.19 minus 5.19. This has to be simplified, right? So if you look at it, all the decimal points are in sync with each other, right? So 38 and this second number, 38.734 and 8.638 has to be added, from which we'll subtract 5.19. So there are various ways of doing it. Either you can add the two numbers first and then subtract 5.19, or you can subtract 5.19 from 8.638 and then add the result to 38, or you can do subtract 5 from 38.734 and then add it to get the required answer. Any way you follow, final answer is going to be the same, right? Here we'll directly try to add and subtract at the same time. Now, as per the BODMAS rule, you know that addition comes first and then followed by subtraction. But just remember, when you're doing additions and subtractions, you need not strictly follow the rule, because subtraction is also one kind of addition. Are you able to follow? As per the rule, the BODMAS rule, we know that we always have to do additions first, then followed by subtraction. But remember, friends, here addition and subtraction actually is one set of operations, additions and subtractions. You can do any one of them depending on your convenience. And why does the rule does not get violated when you are subtracting first? Because subtraction is also a type of addition. For example, we say that 4 plus 2 is equal to 6. What is 4 minus 2? 4 minus 2 can also be taken as 4 plus of minus 2. Instead of saying that I am subtracting 2 from 4, we can say that I am adding minus 2 to 4. So in one way, subtraction is also a kind of addition. And 4 plus of minus 2 will be equal to what? 2. So, considering that point here, addition or subtraction doesn't really matter when you follow the bottommost rule. So let's look at the solution here. Now, what do? We always go from right to left. So 4 plus 8, remember this is plus and next one is minus. So 4 plus 8, 12. And here we do not have anything, right? 0. So 4 plus 8, 12. 12 minus 0 is 12. So we take 2 in the answer and 1 gets carried forward. Then go to the next step. 1 plus 3, 4. 4 plus 3, 7. 7 minus 9. Be careful. 1 plus 3 is 4. 1 is the carry there. 4 plus 3 is 7. 7 minus 9. 7 minus 9 is not possible. So what do? We borrow 1 from the next place, right? This is tens place. We borrow 1 from the next place, right? So that means let's take 1 from 7. So this 7 becomes 6 and this 1 becomes 11. Are you able to follow? I am sure all of you are aware of this logic here. So 11, are you able to follow? Sorry. We can say it becomes 13 or 11, doesn't matter there. Generally, we take it to this place. So we borrow 1 from 7 and make it 13. Now 1 plus 13 is 14. 14 plus 3 is 17. 17 minus 9. What is 17 minus 9? 8. So we get 8 in the next position there. Now look at the next part. It's not 7 anymore. It is 6 because 1 has been given to the next position already. So 6 plus 6. 6 plus 6, 12. 12 minus 1. 12 minus 1 is 11. So we take 1 in the answer and 1 gets carried forward. Right? That's the general rule that we follow with the decimal point now because 3 positions have been taken. Now come to the next units place. 1 plus 8, 9. 9 plus 8. 9 plus 8 is 17. 17 minus 5. What is 17 minus 5? 12. So we take 2 in the answer and 1 gets carried forward. And what is the last step? 1 with 3, 4. Here we do not have any tens places. So your correct answer will be 42.182. Yes or no? The right answer for this question here is 42.182, which is option 4, 42.182. But does this really suit the competitive examination? No. How much time does it take? This method is not suggested. The method is correct. The answer is also correct. But you can't be doing, you can't be finding out the answer in this way in the exam because time is very precious there, right? Even if these kind of simple calculations are done on paper, you end up wasting a lot of time, right? So it's all about trying to be quick. Trying to be as quick as possible, right? So let's understand a smart way of getting the answer, right? There, we'll not write any of these steps. We'll not write any of the numbers to get the required answer. The main problem by following this method here is, method is correct, but it takes up a lot of time because there's a lot of writing part. You have to write the numbers once again, and then you have to do the calculation. So that is the reason, strongly do not follow this, right? Try to follow the smart way, which I'm going to explain you now, right? So let's look at the smart way of getting the answer. Let me just clear this part here. Smart way of getting the answer. Now, what do we do in this method here is, instead of writing the numbers on paper and then doing the calculation, directly try to add the places one by one. Generally, what do? We first add the units places. Then we go for tens places, then hundreds places, and so on. Let's do the same thing without writing the numbers on paper. Now, because here we have got decimal numbers, we have to be a little careful. What do? First, add all the rightmost digits, right? All the rightmost digits, right? Here in this number, the rightmost digit is 4. Here it is 8, and so on. But be careful. Remember, here the numbers are all decimal numbers. These are not integers. These are all decimal numbers. So you have to be careful. The number of digits after the decimal have to be balanced. Here, how many digits do we have? 3. Here we have 3. But in this number, we have got only 2 digits. So if you directly add all the rightmost digits, 4 plus 8, 12, 12 minus 9, you will get a wrong answer. Because this 9 is not the rightmost digit in this case. Understand? We have to balance it first. So what do? Just put a 0 here. For convenience, just put a 0. Now it's all simple. 3 digits after the decimal. Now we can do the calculation and verify what's the correct answer. So what do? 4 plus 8, 12. 12 minus 0. 12 minus 0 is what? 12. So we get 2 in the answer. 1 gets carried forward to the next place. Yes or no? Now add 1 plus 3, 4, 4 plus 3. Are you able to follow? Already we have done the first digit calculation. 4 plus 8, 12 minus 0 is 12. We have got 2 in the answer. One has got carried as a next phase. Now 1 plus 3, 4, 4 plus 3, 7, 7 minus 9. Again the same trouble, 7 minus 9, it's not possible, right? We get a negative value there. So what do? Borrow 1 from the next phase. So in this number, let's say this is 6 and this becomes 13. Now 1 plus 13 is 14, 14 plus 3, 17, 17 minus 9 is 8. We get 8 in the next phase. And remember friends, while following this procedure, the direct addition procedure, you have to eliminate the wrong answer options. And sometimes you may be directly able to get the right answer. Here, of course, in this case, the fifth option is none of this, but still we'll be able to eliminate the wrong answer options in the first, second step itself. For example, I very well know that the answer should end with 2. Look at the options. First option ends with 1. Is it the possible answer? No. Ruled out. First option is ruled out. Second option ends with 9. Is it the possible answer? No. I very well know that the answer has to end with 2. So even this is ruled out. The third option ends with 2. Possible. Fourth option ends with 2. Possible. Fifth option, none of this. Maybe that's the correct answer. Right? But here, because fifth option is none of this, we may not be able to directly mark the answer. But let's say if the fifth option also is some number given to us, which is not ending in 2, that gets eliminated. Right? So if you try to adapt to this elimination procedure, without doing the complete calculation, you may be able to mark the answer sometimes. Right? So be careful. I mean, you should make this a habit that, don't complete the simplification. Just keep looking at the options and see if some elimination is possible or not. Then after looking at 2, if you go to 8, we know that the tens place has to, not the tens place, the second digit has to be 8 from right side. Already first and second options are ruled out. Now if you look at third option, 43.072, we have 7 here. But we very well know that the answer should be ending with, it should be 8 in that case. So even the third option gets ruled out. Now we are left with only fourth option and fifth option. This doesn't help us. Fifth option may be the right answer. Who knows? Fifth option may be the right answer. It can be either fourth option or fifth option. But the point that I'm trying to make here is that, let's say you are solving this question in the last 30 seconds of your exam. What can you do? Just take a risk. Mark fourth option and move to the next question. Because we are not making a blind guess here. Are you making a blind guess? No. We very well know that the first 3 options are not the right answers. Right? In the first 2 steps itself, we have got to know that first 3 options are not the right answers. So answer may be fourth option or fifth option. You can mark any one of them and move to the next one. There are 50-50 chances that your answer would be correct, right? Your chances of going correct is 50%, 50%, half. Probability is 1 by 2. Getting the point? This only when you are doing it in the last 30 seconds. You want to attempt more number of questions, right? So it all depends. Sometimes you have to take a chance in the exam as well, right? So try to follow this idea of eliminating the wrong answer options when you are doing the simplifications, right? Anyway, let's proceed and complete the calculation here. So what happened here? We have got the second digit as 8. 13 plus 1, 14. 14 plus 3, 17. 17 minus 9 is 8. Now move to the third digit, right? 6. 6 plus 6, 12. 12 minus 1, 11. There comes a decimal. And because it is 11, we'll take 1 to the next position. Now 1 plus 8, 9. 9 plus 8. We are now moving on the unit space, working on the unit space. So 1 plus 8 is 9. 9 plus 8. 9 plus 8 is 17. 17 minus 5. 17 minus 5 is how much? 12. 2. And 1 gets carried forward. And then look at the tens place. 1 plus 3, 4. Here we don't have a tens place. So 4. Here again we don't have anything to be subtracted. 4. So your answer here is 4. So the correct answer here is 42.182, which is fourth option. Now try to understand the advantage of following this procedure. We don't have to write all these numbers on paper, and hence we save a lot of time. We are doing, technically both the methods are same. Whatever we have done here, the same thing we are following there, right? We first add 4, 8, 0. That's what we have done, 4, 8, 0. Then 3, 3 and 9. 4 plus 3, 7, 7 minus 9. Because it was not possible, we have borrowed 1 from 7. Same thing has been done here as well. But what's the advantage? What's the smartness here? We don't have to write the steps, and so we save a lot of time. So try to follow this. You just need a little practice, and hence you'll be able to henceforward you will be able to do this very easily and comfortably, right? Let's take just one more question on this. This is very important. Out of 10 questions, 15 questions that you get on simplifications, I can say easily 2, 3 are going to be on these kind of simplifications, right? So avoid these traditional conventional methods and try to get the answers in a smart way, right? So let's move on to the next question. I'll give you one more question from the workbook. Quickly solve that and then we'll take up the next one. Let's look at this. It is minus 676.76 plus 1237.87 plus 897.34 minus question mark should be equal to 1294.25. So I would say this is a little complicated compared to the previous one. We are starting with a negative number, and then the question mark is not on one of the sides, right? It comes in the middle of the left hand side, and there's one number on the right hand side, right? So the question says minus 676.76 plus 1237.87 plus 897.34 minus question mark is equal to 1294.25. Let's look at the options. The first option here is 168.2. Second option says it's 164.2. Third option is 154.2. The fourth one is 164.8, and the fifth option is none of these. Right? Again, about 30-45 seconds should be enough to get the answer. Your time starts now. All right, so I just hope all of you have got the right answer. Let's quickly look at the solution here. Now, what do? You know that you don't have to write the numbers one upon the other to do the calculation. Directly just pick up the question and you'll be able to find out the correct answer. Again, because the fifth option here is none of this, it will be difficult to mark the answer without doing the complete calculation. But if you are ready to take a chance, if you are ready to take a risk there, you can eliminate 2-3 of them and then go for the most probable correct answer, right? Let's look at the complete solution anyway. Now here, if you look at it, we have got numbers on the left hand side, but the question mark is also on the left hand side. And then there's something on the right hand side, that is 1294.25. Now without shifting the numbers on this side, just try to understand what happens. This question mark when taken to the right hand side, it is with a minus sign here. When taken to the right hand side, it becomes plus question mark, plus x. That is what has to be calculated. And plus 1294.25 should be brought to the left hand side. It becomes minus 1294.25, right? So you can write that step and then go for the calculation. Otherwise, if you can understand easily, directly try to find the required answer, right? Just remember, all these numbers remains as it is. Question mark will go on that side. Instead of this question mark here, we'll get 1294.25 with the negative sign, because anyway, when it comes on this side, it is going to be negative, and the question mark there becomes positive. So let's try to get the required answer. What do? Start from the rightmost digit, but be careful. You have to balance the number of digits. Here you have got 2 digits, 2, and 2. So this is okay. We don't have to worry about the number of digits after the decimal. So start working on this. Look at this. This is minus. Take care of the symbols there. Take care of the negative signs. Minus 6. Minus 6 plus 7 is 1. Minus 6 plus 7, 1. 1 plus 4, 5. 5 minus 5. Remember, this is going to be negative there, right? So 5 minus 5. 5 minus 5, 0. So you know that it will be 0 on the rightmost digit there, right? Let us quickly look at it once again. Minus 6 plus 7, 1. 1 plus 4 is 5. 5 minus 5 is 0. Then go to the next space, right? Minus 7. This is negative. Minus 7 plus 8 is 1, right? Again plus 1. 1 plus 3 is 4. 4 minus 2 is going to be 2. And then we get a decimal point here, right? So very well, you know that the answer is going to be ending in 2, 0.20 or 0.2. And here if you look at it, all the options are ending in 2 except fourth option. So that gets eliminated anyway, right? So we know that answer can be 1, 2, 3 or 5. But there's no point in making a guess at this point of time. Just proceed and do a little more calculation there. So up to decimal part, it's all done. Now move on to the unit space. Minus 6 plus 7, 1. 1 plus 7, 8. 8 minus 4 is 4. Answer has to end with 4, or the unit space has to be 4. Now look at the answers 168, unit place here is 8, ruled out. This is 4, here we have got 4, here also we have got 4. Anyway, even the fourth option is ruled out. So the possible answers are either second option, third option, or fifth option. Move to the tens place, right? We don't have any carry here. Minus 6 plus 7 is plus 1, plus 1 plus 7 is plus 8, plus 8 minus 4 is plus 4. Now, tens place, minus 7 plus 3. Look at this, minus 7 plus 3, minus 4, right? It's minus 4. Minus 4 plus 9, minus 4 plus 9 is plus 5. Plus 5 minus 9. Now here comes the problem, plus 5 minus 9. Look at this carefully, the tens place calculation. Minus 7 plus 3 is minus 4. Minus 4 plus 9 is plus 5. Plus 5 minus 9. This is going to be negative on the right left hand side. So plus 5 minus 9. 5 minus 9 is not possible, right? I mean, in the answer we cannot say 5 minus 9 and we cannot write minus 4. What do we do in the general calculation? We borrow 1. We borrow 1 from the next place. So let's borrow 1. We can borrow 1 from 8 here, or we can borrow from 2, or we can borrow from anyone. I mean, preferably go for a positive number. So let's borrow 1. Are you able to follow? Minus 7 plus 3 is minus 4. Minus 4 plus 9 is plus 5. Plus 5 minus 9 is not possible. So let's borrow 1 here. This will become 7 and this becomes 19. Or you can borrow 1 from this number, right? So just try to do that. So what happens here? Now look at the calculation. Minus 7 plus 3, minus 4. Minus 4 plus 19 is 15. 15 minus 9 is 6. So this should be 6. Tens place will be 6. Now what happens? Already the first option, fourth option are ruled out. You know that tens place has to be 6. Third option is also ruled out because here tens place is 5. Right? Either second option or fifth option. It depends on you. If you want to proceed further, do the complete calculation. Or if you feel like second option is correct, just go for it. Right? Anyway, let's look at the hundreds place calculation now. Now what is hundreds place here? Minus 6. Minus 6 plus 2. Or if you are comfortable directly, you can take 12 here. Because anyway, we'll borrow 1, so that becomes 12. So minus 6 plus 12 is plus 6. Plus 6 plus 7. Plus 6 plus 7 plus 6 plus 7 is plus 13. Plus 13 minus 12. We are taking both thousands place and hundred place together, right? Thousands place and hundred place together. So this is minus 6 plus 12 is plus 6. Plus 6 plus 7 is plus 13. Plus 13 minus 12 is 1. So answer has to be 1 here. 164.20. Second option. 164.2. If at all you are not comfortable in taking both thousands place and hundreds place together, take only the hundreds place. It doesn't matter. So minus 6 plus 2, minus 4, minus 4 plus 7, minus 4 plus 7 is plus 3, plus 3 minus 2 is how much? 1. We have got 1. And now go for the thousands place. Here no thousands place, 0. Here we have got 1, plus 1, plus 1. Here we don't have any thousands place, 1. And this is minus 1. 1 minus 1 will give you 0. So even if you proceed for thousands place calculation, after doing the hundreds place, what do you get? 0164.2, that is nothing but 164.2. Now just look at the procedure, neat and clean. We only write the correct answer on paper without having to write all those numbers, which actually takes a lot of time, right? We end up wasting a lot of time. So try to follow this when you do these simple addition and subtraction related questions, right? We have already taken decimal based ones. So it's obvious that even if the numbers are in integers, you will be able to get the right answer without any difficulty, right? Let's move on to the next set of questions. Now we'll look at questions related to fractions. What we have done so far is basic questions, right? And we have followed the traditional method. Traditional method as in we have done the question in a smart way without writing the numbers, but we have not applied any technique as such, any trick. Like I was talking about units place method or digital root method. We'll look at that at a later point of time. Let's now move on to questions related to fractions, right? Additions and subtractions of fractions, or multiplications and divisions of fractions. And then we look at multiplications and divisions of decimal numbers and all that stuff, right? So let's start with, let's move on to the questions based on fractions. Right, so before we actually look at multiplications and divisions of fractions, let's take a simple question which is based on additions, simple additions and subtractions of fractions here. Let's look at this question, right? It says 3 2 by 5 plus 1 2 by 9 equals to 4 4 by 5 minus question mark. And the options here are, first one, 8 by 45. The second option is 7 by 47. Third option here is 4 by 45. Fourth option is 5 by 81. And the fifth option is none. None of these. Right? So the question says 3 2 by 5 plus 1 2 by 9 equals to 4 4 by 5 minus question mark. 8 by 45, 7 by 47, 4 by 45, 5 by 81, and none of this. I'll give you about 40 seconds, should be enough, right? Your time starts now. All right, so I hope all of you have got the right answer for this one. Let's quickly look at the solution. Now you know that these are mixed fractions, right? An integer with a fractional part. 3 2 by 5, 1 2 by 9 equals to 4 4 by 5 minus question mark. Now generally, while solving these questions, what we do is, try to simplify the fraction. Instead of looking at the mixed fraction, we try to convert it to a proper fraction or improper fraction, and then simplify it. Let's look at that procedure, and then I'll give you a smart way of getting the answer. Right? For example, 3 2 by 5. What is 3 2 by 5? How do you simplify? How do you convert a mixed fraction into an improper fraction? Improper fraction, right? What do? Multiply 3 with 5. Multiply the integer part with denominator. So 3 into 5, 15. 15 should be added to the numerator. 15 plus 2, 17. So 17 by 5. Right? That's the idea. I'm sure all of you are aware of that. What do? Multiply the integer part with the denominator. 3 into 5, 15. 15 plus 2, 17. 17 by 5. Likewise, what will this be? 1 into 9, 9. 9 plus 2, 11. 11 by 9. What about this one? 4 into 5, 20. 20 plus 4, 24. 24 by 5. 24 by 5. Minus question mark. Right? Again, what do? Question mark goes on that side, and those two fractions are going to come on this side. So I'll just clear these options. Let's look at the solution. So what do? Take it in a proper manner first, right? Let's take it in a proper way. So this question mark will be equal to 4 4 by 5 minus 3 2 by 5 plus minus 1 2 by 9. Are you able to follow? Question mark on that side. So 4 4 by 5 as it is, minus 3 2 by 5 minus 1 2 by 9. You very well know that the value will become negative when you just take it to the other side. Now, going by the traditional method, 4 into 5, 20, 20 plus 4, 24. 24 by 5 minus 3 into 5, 15 plus 2, 17 by 5 minus 1 into 9, 9 plus 2, 11, 11 by 9. And then what do? We take the LCM of the denominators and try to simplify it. So take the LCM. What will be the LCM? What's the least common multiple of 5 and 9? 45. So take 45 in the denominator. And then we'll try to simplify the numerators. For example, look at this. 5, how many times is 45? 5 into 9 is 45. So multiply 24 with 9. So this is 24 into 9. Right? Minus the symbol here. Minus. What about this? 5 again goes 9 times in 45. So 17 should also be multiplied with 9. 17 into 9. Minus 9 goes how many times here? 5 times. 5 into 11. 5 into the numerator. I am sure all of you are aware of this general procedure. Otherwise, you can directly take this part here as 24 by 5 minus 17 by 5. 24 by 5 minus 17 by 5 will be equal to what? 7 by 5. 7 by 5 minus 11 by 9 should give you the right answer there, right? Or here also again, if you take 9 common, it's the same. Either directly take it as 24 minus 17, 7 by 5, or here you can take 9 common. If you take 9 common, what happens? 24 minus 17 is equal to 7. 7 into 9, right? So what will be the answer? Final answer here? 24 into 9 minus 17 into 9. 9 is common. 24 minus 17 is equal to 7. 7 into 9, 63. 63 minus 5 into 11, 55, divided by 45. So this will be equal to 8 by 45. That's your answer, 8 by 45, which I believe is option number 1 as per the given options. Right? 8 by 45 is the correct answer. But friends, this actually is a lengthy procedure. Even though you take directly here it as 7 by 5 minus 11 by 9. Again, you have to take the LCM as 45. 9 times 63, 5 times 55, and that will give you 8 by 45 as we have got here. But then whatever you do, this is somehow a lengthy procedure, right? Directly or indirectly, we waste a lot of time in this process here. We don't realize that we are wasting our time. So what is the smart way of solving this question? Let's look at it. Never try to convert this improper fraction into never try to convert this mixed fraction into an improper fraction. Don't do that, right? Instead of that, try to split the mixed fraction into integer part and the fraction part. That will give you the answer much faster. Let's look at the solution, right? Instead of doing all this stuff, what we'll do here is take this 3 2 by 5 as 3 plus 2 by 5, or I'll try to simplify from this step. Just remember what kind of calculation you have done here. 24 into 9, 17 into 9, 5 into 11, right? And here we are able to take 9 common. So it was easy. 24 minus 17, 7 into 9. But let's say if it is 24 into 8, you have to multiply that. 24 into 8 has to be multiplied, which should take some time. Even though you are good at calculations, it will take about 2-3 seconds. 17 should be multiplied with 9. Again, 1 or 2 seconds, right? So it takes time here for simplifying this numerator if you convert the mixed fraction into improper fraction. Now, without doing this, how will we get the answer faster? Let's look at that. So what do we do here? This will be equal to 4 by 5 minus 3 2 by 5 minus 1 2 by 9. Right? Now let's understand how does it give us the answer faster. What do we do? As I've mentioned, split the mixed fraction into integer part and the fraction part. So 4 by 5 can be taken as 4 plus 4 by 5. Yes or no? 4 plus 4 by 5. For example, what is 3 and a half? What do you mean by 3 and a half? 3 1 by 2. How do you take it? This is 3 and a half. 3 plus half. That's the idea, right? 3 and a half, or for example, 5 1 by 4. 5 1 by 4 is what? 5 plus 1 by 4. So that's the idea. Any mixed fraction can be split into integer part and the fraction part. So we'll try to do that for all the given fractions. So 4 plus 4 by 5 minus of, look at this, 3 2 by 5 will be equal to 3 plus 2 by 5. But when you split it, it becomes minus 3 minus 2 by 5. Negative sign is applicable to both integer as well as the fraction part. So minus 3 minus 2 by 5. And then 1 2 by 9 is 1 plus 2 by 9. Apply negative sign to both of them. Minus 1 minus 2 by 9. Now try to do the calculation. What kind of calculation will you do here? Do the calculations for the integer part separately and the fractions part separately. Are you able to follow? We'll do the integers calculation in one shot and then the fraction calculations here. Let's see what happens. 4, don't worry about the fraction part. 4 minus 3 is how much? 4 minus 3 is 1. 1 minus 1, 0. Yes or no? 4 minus 3 minus 1 is what? 0. So there is no integer part. Now look at the remaining parts. What are those? Fractions. 4 by 5 minus 2 by 5 minus 2 by 9. Now what do? Now take the LCM. 5 and 9, the LCM is 45. Now you might be wondering, how does it make it easy? Here also we have to take LCM. In the previous procedure also we have taken LCM. So how do you say that this method will give you the answer faster? Look at this. Now you will realize why this gives you the answer faster. 5 goes how many times? 9 times. So 9 into 4. 9 into 4 is how much? 36. If you remember, in the previous case, it was 9 into 24. That's the difference. 9 into 24 will take more time when compared to 9 into 4. Yes or no? Likewise, next step. 5 goes how many times? 9 times. 9 into 2. Earlier case, it was 9 into 17. If you remember, 9 into 17. 9 into 17 takes more time when compared to 9 into 2. It's 18. And last step, 9 goes how many times? 5 times. 5 into 2. 5 into 2 is 10. Earlier it was 5 into 11. Though 5 into 11 is simple, 55, but 5 into 2, 10. Much easier, right? And then remember, though this question in the previous method also appeared to be a little easy because the values were not typical. If the denominators are like 5, 7, 11, all kind of prime numbers, it takes a lot of time to do the multiplications and arrive at the numerators. So that is the reason. Remember, always split the integer part and the fraction part. You will get the answer much faster. So look at this now, minus 10. What is 36 minus 18? 18. 18 minus 10? 8. 8 by 45. That's your answer. So practice on this method. What do? Just split the integer part and the fraction part and do the calculations. But one point which you have to be careful about is the negative sign. Right? Generally, when you are solving this question in the exam, you are in a hurry. So what do? Minus 3 2 by 5 will be taken as minus 3 plus 2 by 5. Many times I have found my students committing this kind of mistakes, right? Because they are in a hurry. So avoid this. Avoid this. Minus 3 2 by 5 is not minus 3 plus 2 by 5. It is minus 3 minus 2 by 5. Right? So just be careful. And if you follow this procedure, definitely you'll get the answers faster. Right? So the correct answer here is 8 by 45. Let's move on to the next one. Let us now look at a question where multiplications and divisions of fractions are involved. This again is considered to be a kind of complicated one. Generally, we find students going wrong here. So let's look at one or two examples on multiplications or divisions of fractions. For example, 3 6 by 17 divided by 2 7 by 34 minus 1 9 by 25 equals to question mark squared. Options are, the first option here is 2 by 5, second option is 3 by 5, third option is 5 by 2, fourth option will be 5 by 3, and the fifth option is 4 by 7, right? So 3 6 by 17 divided by 2 7 by 34 minus 1 9 by 25 equals to question mark square. 2 by 5, 3 by 5, 5 by 2, 5 by 3, and 4 by 7. I think this shouldn't take more than 30 seconds, but maybe because you're doing it for the first time, 45 seconds. Your time starts now. Alright, so I hope all of you have got the right answer. Let's look at the solution now. Now remember friends, when it is additions and subtractions, splitting the improper fraction into, splitting the mixed fraction into two parts would be useful. But generally when questions involve divisions and multiplications, it would be better if you convert the mixed fraction into an improper fraction, right? So depending on what kind of operations we need to do. If it is a additions and subtractions based question like the previous one, just split the integer part and the fraction part separately, right? If it is involving divisions, etc., divisions and multiplications, it would be better if you go for converting the mixed fraction into an improper fraction. So that's what we'll try and see what is the answer here. So 3 6 by 17. So 3 into 7 51, 51 plus 6 57, 57 by 17 divided by 2 7 by 34. 2 into 34 is 68, 68 plus 7 is 75, right? 75 divided by 34 minus 25 plus 9. 34 divided by 25 equals to question mark square. Now you have to be particularly careful when it comes to these kind of questions which involves question mark square, right? You have to find out what comes in place of question mark. So directly sometimes what happens, we simplify this left hand side part, whatever answer we get we mark that as an answer, whatever we get here we mark that as an answer. It is wrong because on the right hand side it is question mark square, so we have to take square root of that result that we have got, and then we'll get the final correct answers, right? So be careful. In a hurry, don't mark wrong answers and don't commit such silly mistakes. Now, after converting these mixed fractions into improper fractions, what kind of technique can you apply? Remember, friends, I'm going to explain something very, very important and crucial now. Whenever you have a division between two fractions, generally it's something like this. If it is a by b divided by c by d, what do? We take it as a by b whole divided by c by d. Then d goes in the numerator and b and c, opposite numerators and denominators get multiplied. So this will be equal to a into d divided by b into c. So that's what generally it is done while solving divisions of fractions, right? While taking divisions of fractions, one fraction divided by the other one, a by b by c by d. So multiply the opposite numerators and denominators. Numerator of the top one with the denominator of the bottom fraction, right? So a into d and vice versa here. So B into C. So A into D by B into C. But instead of worrying about all these steps, just remember a very important and a very smart technique here. Instead of doing all this drama in the exam, simple procedure here is convert this division into multiplication. Instead of division, put a multiplication sign and reciprocate the fraction. Reciprocate the fraction. Reciprocate the second fraction. What do you mean by reciprocating a fraction? The numerator and denominator gets interchanged. So instead of taking all, if you see what's the idea behind that, instead of doing all this, if you look at it, this is what A into D by B into C. Can I take it as A by B into D by C? Yes, A by B into D by C. Now try to compare with the original part. It was A by B divided by C by D, which results as A by B, first fraction as it is, division has become multiplication. C by D becomes D by C. So simple idea here is convert the division to multiplication and reciprocate the second fraction. And why are we trying to convert this to multiplication? Because multiplication of fractions is easier compared to division. At least it looks to be easy. It may not really be easy, but it looks to be easy when compared to division of fractions. Simple logic is replace the division with multiplication and reciprocate the second fraction. So going by that, what do we get here? 57 by 17 into 34 by 75 into 34 by 75. And friends, here I am writing the next step so that I can explain it to you clearly. Otherwise, if you are doing it in the exam, you can just put into mark here and reciprocate this part. That scribbling part can be done here, right? So try to cut short the number of steps. I may be writing all the steps here, but based on how you understand, you can cut short on the number of steps. So 57 by 17 into 34 by 75 minus 34 by 25. Now what do? 17 goes 2 times. Yes or no? So 57 into 2 by 75. So that can be taken as 57 into 2 is how much? 114 by 75 minus 34 by 25. Now again the same story. You have to take the LCM and do the calculation there, right? Now understand, if you are smart, instead of writing that LCM 114 and all that, you know that why do we take LCM? We want the denominators to be equal. So try to make the denominators equal. Simply make the denominators equal. Like in the previous case also, in the previous question, some fractions are ending in 5. I mean the denominator was 5. Some other way having denominator as 9. So we take the LCM 45. So it becomes equal. Denominator become equal in all the cases. That's what we'll do here. So it's easy to convert 25 to 75. How do you do that? Multiply this with 3. But remember, when you multiply the denominator with 3, the numerator should also be multiplied with 3. Yes or no? In any given fraction, when both numerator and denominator are multiplied with the same value, we do not change the fraction. The fraction value does not get changed. So multiply both numerator and denominator by 3. So 34 into 3 becomes how much? 102. 33 is 90, 4 3 is 12. 90 plus 12, 1 not 2. And 25, 3 becomes 75. So what happens? 75 and 75, denominators are equal. When the denominators are equal, I can directly subtract the numerator. So this becomes 12 by 75. Yes or no? 114 minus 102 is 12. 12 by 75. What is 12 by 75? 12 by 75 can be taken as 3 4s and 3 25. 4 by 25. 4 by 25. Yes or no? So what is our left hand side? 4 by 25. Now fortunately here 4 by 25 is not there in the given options. But let's say if one of the options is given as 4 by 25. Let's say this fifth option is given as 4 by 25. There will be many students who will mark fifth option as the answer, because they missed on one simple point here, that the right hand side was question mark square. So what we have obtained here is question mark square. Yes or no? If you take it as x, we have got to know that this is equal to 4 by 25. And what we are required to find out is this part, question mark. Take it to the other side. Are you able to follow? Apply square root on both the sides. So here we can say the question mark will be equal to, it will be equal to square root of 4 by 25. How much is that? Square root of 4 by 25? 2 by 5. Hence the correct answer is option number 1. So that was one silly mistake which you need to avoid while solving such questions, right? Be careful. Not only in questions based on fractions. Wherever you find question mark square or square root of question mark, which we tend to mark the wrong answer because we are doing it in a hurry, right? So simple logic here is convert the divisions to multiplications. You will get the answers faster. Let's look at one more question, and then we'll look at some of the smart ways of getting the answers. The methods which I was talking about, unit space method and digital root method, etc. Let's look at the next question on fractions. 4 1 by 2 plus 1 divided by 2 8 by 9 minus 3 1 by 13 equals to what? Options are 23 by 13, first option. Then we have 13 by 23. Then 25 by 13. Next is 25 by 26. And the fifth option, as usual, is none of this. So that's the question there. What do we do again? As I've mentioned, BODMAS rule, that is what you need to follow. First, always simplify the bracketed part. Now, in such cases, always go for simplifying what is within the brackets, right? Anyway, division here, so generally we'll go for division also. But if at all, inside the brackets, we have multiplications or subtractions or additions, right? Even then, you have to go for simplifying the bracketed part. So, always follow the rule there, the hierarchy there. First, highest priority is given for bracketed. Now, simplify this part. 1 divided by 2, 8 by 9. Let's simplify. Division actually, right? So, division means what? You try to simplify this mixed fraction into an improper one. So 2 into 9, 18. 18 plus 8, 26. 26 by 9. Yes or no? 1 divided by 2, 8 by 9 can be taken as 26 by 9. Now understand, 1 is getting divided by 26 by 9. What happens? It reciprocates. Yes or no? Or otherwise, going by the rule, this is 1 divided by 26 by 9. You know that you can always convert this to multiplication and reciprocate the second fraction. Yes or no? 1 divided by 26 by 9. This 1 can be taken as 1 by 1. So fraction divided by fraction, multiply and reciprocate. So 1 divided by 26 by 9 will become what? 26 by 9 reciprocates. So 9 by 26 with a multiplication. So 1 into 9 by 26. How much is that? Overall 9 by 26. So this part comes out to be how much? 9 by 26. So 4.5 plus 9 by 26 minus 3 1 by 13 can be taken as 39 plus 1, 40 by 30. 40 by 30. Right? And 4 1 by 2 can be taken as how much? 9 by 2. This part is 9 by 2. Now try to look at this. 9 by 2 plus 9 by 26 minus 40 by 30. You have to take the LCM there, right? Going by that rule. So LCM. What is LCM here? 26 is the LCM. 2 goes how many times? 13 times. 13 into 9. What is 13 into 9? 170. And 26 goes 1 time. So directly we have 9 minus 13 goes how much? How many times? 2 times. 2 into 40 is 80. So 117 plus 9 is 126. 126 minus 80, it is 46 by 26, which comes out to be 23 by 13. So the answer for this question here should be 23 by 13, option number 1. So more or less what we have done in the previous question, right? Simply try to, what I'm trying to make it clear here is that don't write step by step. You must be able to analyze this and directly write the value, right? You don't have to write all the intermediate steps here. 2 8 by 9 is 26 by 9. 1 divided by 26 by 9 will be 9 by 26. Then 9 by 2 plus 9 by 26 minus 40 by 30. Simplify and we have your answer. Now let's look at the next question. We will now move on to typical questions. I'll just take up random questions from the book here, and we'll try to get the answers. And at the same time, we'll learn the smart ways: unit digit method, digital root method, etc. So the next question here: 6 into 136 divided by 8 plus 132 divided by 628 minus 26.25 equals to what? Options 18, 17, 28, 19, none of these. Right, so 6 into 136 divided by 8 plus 132 divided by 628 divided by 16 minus 26.25. So that's like a complicated numerator which has got some simplification within it and a similar denominator. So simplify the numerator and denominator respectively and then go for the division part, right? I think 45 seconds you should be able to get the answer. Your time starts now. Alright, so I just hope all of you have got the right answer for this one. Understand friends, most of the questions on simplifications, though they appear to be complicated, it all depends on your speed maths ability. It all depends on how quickly can you do simple calculations, right? It's not about doing complicated calculations fast. Even if you can do the simpler ones very quickly, you'll be able to arrive at the right answer much faster, right? So it's all about that, how quickly you simplify using the BODMAS rule and how quickly do you do the individual calculations. Now let's look at the numerator first. 6 into 136 divided by 8 plus 132. Going by the BODMAS rule, first you have to go for division. Yes or no? Here we have got multiplication, division, and addition. So first is division. So go for division there, 136 by 8. Or understand, in case of multiplication and division, you can always come from left to right. Right? For example, in this case, even if you multiply 6 with 136 first and then divide by 8, you are going to get the same answer. So either follow division first, then multiplication, or you can proceed from left to right when it is only divisions and multiplications involved, right? So let's anyway go by the procedure. 136 by 8. What is 136? Now here it is very, very important. If you start doing 136 by 8 in this manner, 8 ones are 8 and 5 and 6 and all that, it's going to take up a lot of time, right? If you do these kind of calculations on paper, you end up wasting a lot of time. So you have to be really quick in doing these simple calculations. 136 by 8. What do you do? If you have gone through the speed maths video, split the numerator. 136 is not 136. I can say it's 80 plus 56. So 80 by 8, 10, 56 by 8, 7, 10 plus 7, 17. So this part becomes 17. Then 6 into 17 plus 132, multiply. Next multiplication, 6 into 17 is 102, right? You must remember this, 102. 102 plus 132. 102 plus 132 is 234. So the numerator here is 234. Divided by, now comes the denominator. Now, look at this. This is going to be a little complicated because we have got decimal parts here, so you have to do it carefully. 628 divided by 16. How much is 628 divided by 16? Now this, if you are able to do quickly, no doubt you will get the answer faster, right? This is where I believe most of you will get stuck. 628 divided by 16. There is no point in doing that on paper. Again, if you start doing it in this way, I would say, though you get the right answer, you are wrong. Your method is wrong. You should be able to divide 628 by 16 orally, mentally. What do? Split the numerator, 628 by 16. Now don't tell, why are you writing on paper? Because I'm trying to explain you, right? Otherwise, we can just do it mentally. 628 by 16. What's the logic? Always split the numerator in terms of some multiple of denominator there. 628, can I take it as 640 minus 12? I can take it as 640 minus 12. Why are we taking it as 640 minus 12? Why can't I take it as 600 plus 28? Because 640 is a multiple of 16. 16 into 4 is 64. 16 into 40 will be 640. So the idea here is try to break the numerator in a way that at least one part is some multiple of denominator here. So I'll take 628 as 640 minus 12 by 16. Are you able to follow? Now try and understand. You don't have to write this step. It's all visualization. 640 by 16 will be how much? 40. 64 by 16 is 4. So 640 by 16 will be 40. 40 minus, what's the left out part? 12 by 16. What is 12 by 16? 12 by 16 is 3 by 4. 3 by 4 is 0.75. So 40 minus 0.75. How much is that? 39.25. Are you able to follow? Same thing you try to do on paper, it's going to take a lot of time. I mean, definitely more time when compared to the direct mental calculation, right? And I would say even these steps are not required. The other way of doing it is try to break 628 in terms of some other multiple of 16. For example, it can also be taken as 480 plus 148. 480 plus 148 is 628. Yes or no? 480 plus 100, 580 plus 48, 628. 480 plus 148. Now why 480 plus 148? Because 480 is divisible by 16. 480 by 16 is 30. 148 is left out. Now how do you split 148? 148 should be divided by 16. 148 is how much? 148 can be taken as 144 plus 4. Now you may ask me, why 144 plus 4? Because I know 144 by 16 is 9. 16 is 9 is 144. So 144 by 16 is 9. Already we have 30 and 9. 39. What is left out? 4. 4 by 16, 1 by 4. 1 by 4 is 0.25. 39.25. So either you split it this way or that way, finally you are going to get the same value, 39.25. But then how quickly you do it is what matters. So this part is 39.25 without writing anything on paper. 39.25 minus 26.25. Forget about the decimal parts. 0.25, 0.25 gets cancelled. 39 minus 26. How much is that? 13. So your answer here is 234 by 13. Again, how do you divide? Do not put pen on paper. Don't start doing the conventional division. That takes a lot of time. Split 234. 234 can be taken as, I would say, a faster way of getting the answer here is take it as 260 minus 26. Why 260? Because I know 260 is divisible by 13. 260 minus 26 is 234. 260 by 13, 20. 26 by 13, 2. 20 minus 2, 18 should be the answer. That's your answer, 18. And believe me, if you are not writing all these steps, it's going to be very neat, clean procedure. And see, it's not about doing it neatly. You're not going to get more marks if you solve the question neatly. It's about cutting down the number of steps, right? The less you write on paper, the faster you get the answer. The more marks you can score, right? The faster you become, and your score also improves. So that's the idea. That's the idea behind not writing steps on paper, trying to do it neatly, right? So try to understand all the speed maths techniques that you have learned. I mean, you have gone through the speed maths video. There are 16 parts in it, where we have learned additions and subtractions, various multiplication techniques, divisions, square roots, squares, cube roots, cubes, percentage related calculations. All these are very, very important, right? All these methods and techniques that we have learned there are going to help you somewhere or the other when you are solving a question related to simplifications, right? So that's what you need to follow here. Let's move on to the next one. So let's look at this question. 441 to the power of 1 by 2 into 207 into 343 to the power of 1 by 3 divided by, well, there's a flower bracket here. Then again we have 14 squared into 529 raised to the power of half equals to what? So the options here are 5.75, 6.75, 7.75, 6.25 and 6.5. So 5.75, 6.75, 7.75, 6.25 and 6.5. So 441 power 1 by 2 into 207 into 343 power 1 by 3 divided by 14 square into, right, this is 14 squared into 529 power 1 by 2 equals to what? Now, how do you solve this question? Apply the BODMAS rule. What does the rule say? First, to always go for the bracketed part. You have to simplify what is within the brackets. Now here we have got different brackets. Again, remember, within brackets also there is some hierarchy that we need to follow. For example, you know, there are different brackets. There is something called as flower brackets. Then we have square brackets. Then curved brackets, right? The general brackets that we use, right? So in general, it's always an inside out operation. When there are multiple brackets, like in this case, within the brackets we have got brackets, right? Here again within the flower brackets we have got simple brackets there. So whenever there are multiple brackets, always try to go inside out, right? The operation is inside out, right? So enter the innermost bracket and try to keep moving outwards. That's the logic. And in general, the hierarchy here is that always simplify this kind of bracket first, then go for square ones, and then go for flower ones. But you need not try to remember this or mug it up. Just remember inside whatever within the brackets, whatever is there in the bracketed part, try to simplify, and then keep moving outwards, and you will get the right answer. Okay. Strictly speaking, the rule is not BODMAs. The rule is VBODMAs. But generally, this is not required when we are doing these calculations. What does this V stand for? V stands for Winkelum. This is another kind of bracket. For example, 4 plus 6 minus 3. And if it is given this way, this is known as a Winkelum, right? A bracket. This is a kind of special bracket. So 4 plus 6 is actually inside the brackets here. That's the idea, right? Generally, when we say 3.3 bar, what does it mean? 3.3333. So that's the idea. That's what is called as bar. But here, this is not acting as a bar. This is called Winkelum, where we add 4 and 6 first. 10 minus 3. 7 will be the answer, right? You cannot take something else. Like for example, anyway, here even if you take 6 minus 3 plus 4 will give you the same answer, but that would be wrong, right? Let's say if it is multiplication, right? So if you say 6 into 3, 18, 18 plus 4, 22 is the wrong answer. Why? 4 and 6 are inside the bracket. 10 into 3, 30 is the correct answer. So that's what is known as Winkelum, but generally not required. You don't have to worry about that part. Anyway, you have understood what is meant by that. So try to simplify this part now. You should have got the answer by now, right? Look at this. 441 power 1 by 2. Power 1 by 2 means what? Square root, right? Half. Power half is what? Square root. What is square root of 441? 21. What is What is power 1 by 3? Cube root. What is cube root of 343? 7. 7 cube is 343. Likewise here 14 squared, 196. Again understand, these are all known as, this is what stands for O. BODMAS. What is O? The other operations of exponents, powers, indices, right? All this comes under that O part, right? Other operations or of orders and these kind of operations. So square root, cube root, square root, all this comes under O, right? So 529 square root. What is square root of 529? 23. Yes or no? 23 square is 529. This is 23, right? So 21 into 207 into 7 divided by 196 into 23. Yes or no? 14 square is 196 into 23. 529 square root is 23. Now try to simplify this. What do you see? If you really look at it, 21 into 207 into 7 divided by 196 into 23. Yes or no? 196 into 23. Now, someone who is really good in calculations, he would know that 23 goes 9 times in 207. Yes or no? You don't have to worry about 23 into 10, 230 minus 23 is 207. 9 times, right? What about what else can be done here? 9 does it get cancelled in 196? No. 7, yes. 7 goes how many times in 196? 7 goes how many times? 140 and how much is that? 140 and 56. So 28 times. 28 times. 21 by 28. This is 3 times and 4 times. So overall this is 3 by 4 into 9. What is 3/4 of 9? 6.75. Yes or no? 3/4 of 8 is 2. So 3/4 of 8 is 6. 3/4 of 1 is 0.75. So 6 plus 0.75, 6.75. So the answer for this one is 6.75. So this is all what you need to do. Simple calculations. Try to do it as quickly as possible. Follow the bottom-up rule and you'll be getting the right answers. Let's now move on to the next part. That is units place method. Let me explain you what is meant by units place method. Now this is something which will be useful in eliminating the wrong answer option, right? Unit digit method or units place method, whatever you call it, right? This may not give you the answer always, but in certain cases, definitely you'll be able to find out the right answer, right? For example, what does it actually mean? Units digit method. Remember, there is some 4-digit, 5-digit number which ends with 5. And there's another number that ends in 3. Can you tell me what will be the answer ending in? Don't worry about the remaining part of the number, right? I only know that one number ends in 5, the other number ends in 3. Can you directly say the answer has to end in 8? Yes. Why? Always you add the units places first when you go for addition. So 5 plus 3, 8. Answer has to end in 8. What is going to be the tens place? We are not aware of, but definitely the units place is going to be 8. Similarly, subtractions. For example, 5 minus 3, let's say. This will end with what? 2. Because we will first subtract this one with the next one, right? Provided this is larger. This number has to be larger than the second one, right? So you understand that 5 minus 3 will give you 2. Likewise, multiplication, 5 and this number is multiplied with 3 or whatever it might be, 6, 2, whatever you take, right? One number ends in 5, the other number ends in 3. What will be the product ending with? It will end with 5 because first we multiply the unit places. Going by the traditional method, what do? First multiply the unit places. Or even if you go by the smart method that we have learned in speed maths video, IXI technique or IX star XI technique. What do? First multiply, the vertical number there, unit places. So 5 into 3, 15. We take 5 in the answer, 1 gets carried forward. So the answer here will end with 5. Yes or no? Answer will end with 5. Division, for example, let's say one number ends in 5, other number ends in 3. Can you tell me what will come in the unit place here? What comes in the unit place? Simple. Look at this. 5 plus 3, 8. 5 minus 3, 2. Unit places. 5 into 3 will give you 5 with some value, right? There's some number here. Some 4-digit, 5-digit number everywhere, right? So likewise, here we have some 4, 5-digit number, some other number which have to be divided, right? Numerator by denominator. One ends with 5, the other ends with 3. Can you tell me what will come in place of question mark? But generally, when I ask this question in the class, I get a variety of answers. For example, 5 by 3. Some say the answer will end with 5. Some say the answer will end with 9. Some say the answer should end with 0.67. And so on, different answers. Now, I'll tell you what's the reason behind giving these answers. Right or wrong, we'll get to know. But let's understand what's the reason that they are giving these kind of answers. They say it may be 15. 15 by 3 is what? 5. Yes or no? We are not aware of the units tens place, but let's take it as 15. 15 by 3, 5. Or 45. Are you able to follow? 45 or 9 may not be possible. 45 by 3 is also 5. It will end with 5. But let's say 0.67. They properly divide 5 by 3. 5 by 3 is how much? 1.67. So the answer has to end with 0.67. See, the point here is all these answers are wrong. All these answers are wrong. Why? Here we have no idea about the tens place. If it is 15, if it is 0, let's say 0.5, 0.5 by 3, okay, 0.67. If it is 1.5, 15 by 3, 5. If it is 2.5, 25 by 3, 25 by 3 will be what? 8.33. If it is 35, it will be how much? 11.67. Are you able to follow? So the point here is we'll be getting different values. And moreover, these are all wrong answers because in all the previous cases, you can directly work on the unit places. Why? Addition, multiplication, subtraction, all these start from right to left. First we work on unit places, then we work on tens places, then we work on hundreds places, and so on. So that is the reason I can work only on unit places and tell you what's the unit place going to be in the answer. But in case of division, do we do it that way? Do we divide the unit places first, then do we divide tens place, hundreds place, and so on? No, that's not the idea. Division, we take the number as a whole. Are you able to follow? When you divide, for example, let's say it is 145 divided by 23. Do we divide 5 by 3, 4 by 2, and 1? If that is the case, the answer should be what? 5 by 3 is 0.67, 4 by 2 is 3, 4 by 2 is 2, and 1 by 1 is what? I mean, this is what? Stupid. This is not the correct way of doing it. What do we do in that case? We take 23 as a whole. 23 is number that has to be dividing 145, or 145 as a whole should be divided by 23. So in case of division, understand the unit place method does not work. Question mark remains question mark. What does it mean? We don't know what comes in the unit place. It can be any value. It can be any value. It may be a decimal answer, or it may be 1, 2, 3, 4. It depends on what kind of numbers are given. So just follow this while solving certain questions, right? Remember, you can always understand the unit place when it comes to addition, subtraction, multiplication, but not in case of division. Now let's take some questions where you can generally solve using the bottommost rule, simplify and get the answer. But otherwise, if you go for unit place, maybe you'll be able to get the answers much faster, or you may be able to eliminate the wrong answer options. So let's look at some of the questions then. Let's take the next question, which I'll write on the board. 12 into 19 plus 13 into 8 equals to 15 into 14 plus question mark. So options are 124, 122, 126, 128, fifth option none. Now let me tell you friends, because fifth option is none of this, unit place digit is actually not going to work. That may not help you in getting the right answer. But then definitely you'll be able to eliminate some of the answer options here. I'll tell you the reason. If you really look at the options here, first answer ends with 4, second answer ends with 2, third answer ends with 6, fourth one ends with 8, fifth one is none of this. Now in the first 4 options, all the unit spaces are different, which means if I am able to find out the unit space of the given question, then I can verify which of them are right, or to put it right in a right way, which of them are wrong. We may not be able to find out the right answer, but we'll definitely be able to find out the wrong answers. And by any chance, if fifth option is also given as a number, then you're done. You don't have to simplify the whole part there. You can just do some verification, unit space method, and get the required answer. Let's see how it works. Here anyway, we have to do the complete calculation as I've mentioned, because fifth option is none of this. But how can we apply unit digit method? For example, 12 into 19. Don't worry about what is 12 when multiplied by 19. Of course, you can do that. 12 into 19 will be how much? 228. 240 minus 12. That's very simple. Very simple for Banker's Choice students, because you have gone through that speed maths video. You know how to multiply these questions, I mean these kind of numbers faster. But then apply unit space method. One number ends in 2, the other number ends in 9. 2 into 9, 18. So the answer has to end with 8. That's it. I know that this number ends with 8. Plus 13 into 8. 13 into 8 will be some value. 130 minus 26, 104, whatever it might be, right? But then don't worry about that. 3 into 8. Unit place here is 3, unit place here is 8. 3 into 8, 24. Answer ends in 4. So I can say that this number is going to end in 4. Now overall, if you look at the left hand side, one number ends in 8, the other number ends in 4. Can you say the answer ends with 2? Yes or no? Answer has to end with 2. 8 plus 4. One number ends in 8, the other number ends in 4. Overall, the answer has to end in 2 equals to something. What is on the right hand side? Let's look at that. So we very well know that the answer is going to end in 2. Here also you have to balance that part. One part, second part. I mean, first term, second term. Just try to balance that. 5 into 4. 0. 5 into 4 is 20. Answer ends with 0. So this is equal to 0 plus question mark. Now try to understand. Complete left hand side ends with 2. Right hand side we have got 2 terms. First term is 0. What should be the second term so that the unit spaces are balanced? Second term should be 2. Yes or no? 0 plus 2 will only give you 2. Is there any other possibility? No. So I very well know that question mark should end with 2. The answer has to end with 2. Verify from the options. At least in this case, we'll be able to eliminate 3 options. Yes or no? First option 124. Is it possible? Not possible. I am looking for unit space to be 2. Second option 122. You cannot mark this as an answer. What you can only say is possible, because the answer is ending in 2. It may be 122, 132, 142, 182, 112, 22, 32. Anything is possible. Possible. 126 ruled out. 128 killed. Fifth option always true. I mean, because it is fifth option, there is always a chance that this may be correct, right? It may be 122 or 132. Now again, I'll repeat the point here. If you remember in the beginning of the session, I was mentioning that sometimes you have to take a chance. If you don't want to waste your time in doing that complicated calculation, or if you find it to be difficult, if you want to quickly move to the next question, or if this is the last 30 seconds of your exam, don't bother about doing the complete calculation. What do you do? Take a chance. Mark second option. I'm not saying that you will be correct. You may be wrong also, but then fair chances, 50% chances that this is the correct answer. Otherwise, this is the correct answer. Or if you think that no, this is not correct, none of this is correct, mark none of this. Any one of them has to be correct. We are not making a blind guess. I'm 100% sure that first, third, and fourth options are wrong. So that's the idea here. If at all you say that no, I don't want to take any chance, I don't want to take risk, I want either 1 mark or I leave it, I don't want to go wrong, then do the complete calculation. Complete calculation will not take much time. It will take about 30 seconds. Yes or no? 12 into 19 you know, 13 into 8 you know, add them. I don't have to explain all this. Speed maths, bot maths, follow and you will get the answer. 15 into 14. What is 15 into 14? 210. Plus what? Will give you the answer. So that's how you can apply unit space method in answering some of the questions. Let's take 1 or 2 more examples. So complete solution if you want, I don't have to explain. Believe me, in all these questions that we have in the workbook, also in the Banker Choice workbook and training guide, questions on simplification, you can solve it. I mean, it's what? Addition or subtraction or multiplication or division, which you all are well aware of. What matters is how quickly you get the answer, how quickly are you able to multiply the numbers or divide or add or subtract them, right? So that's what we are trying to understand in this session of simplification, the smart ways of getting the answer, and follow the bottom-up rule. That is very, very important, right? Let me give you a question now. Look at this. Question mark squared plus 65 squared equals to 160 squared minus 90 squared minus 7191. I'll give you the options: 75, 77, 79, 81, and fifth option is none of these. How much time do you think will it take? 30 seconds. The time starts now. All right, so hope all of you have got it. I can see many answers coming in. Let's look at the solution now. How much time will it take? Ideally, if you want to do the complete solution, 65 square, 160 square, though easy, but it would take some time. 65 square, how much is 65 square? 4225. 160 square, it will be 6,40,000, right? Then 90 square will be how much? 8,100, then 7191. So you can do that simplification part and then take the square root, because this is question mark square. Remember, I told you, you have to be careful about these kind of questions, and you'll be able to get the answer. So it would take about 45 seconds, not more than that, right? Even if you do the complete solution, it would not take more than that. But a smart way of getting the answer will help you arrive to the correct answer in just about 5 seconds, I can say, or maximum 10 seconds. What is that? Units place method. Look at this, 5791. So make some sense. Go for units place method. If at all you're ready to take a chance, because fifth option still is none of this. If all the answers are ending in 5, let's say, or all are ending in 7, then there's no point in going for units place method, right? So depending on the option, you have to select the method, right? Now, 5 square, when a number ends in 5, you very well know this from the speed maths video now. When a number ends in 5, its square always ends in 5. So I know that this number is going to end in 5. When a number ends in 0, its square always ends in 0. So this number is going to end in 0. When a number ends in 0, its square always ends in 0. So this is going to end in 0. And this is a simple number, direct number there, which ends in 1. So this number ends in 1. So 0, minus, and minus, right? Same signs, whatever signs are here. And question mark square, plus. The left hand side anyway cannot be simplified because question mark there has to be calculated. Let's look at the right hand side. Yes or no? 0 minus 0 is 0. One number ends in 0, the other number ends in 0. So 0 minus 0 is 0. 0 minus 1. Now here comes a very important. 0 minus 1 is what? Minus 1? Yes, minus 1. 0 minus 1 is minus 1. But remember, there is a larger number. What do? We borrow 1. We borrow 1 from the tens place and we try to make it positive value. So 0 minus 1 is what? 10 minus 1, 9. I can say that this right hand side here ends in 9. I'll just repeat this. 0 minus 0 is 0. 0 minus 1, ideally it's minus, strictly speaking, minus 1. 0 minus 1 is minus 1. But here you are looking at the digits, units place. 0 minus 1. What do? We borrow 1 from the next place. So 10 minus 1 makes it 9. So this right hand side here is going to end in 9. Now try to compare this part with this part. Question mark square plus 5 should be equal to something ending in 9. Look at this. If I try to balance this, I want 9 to be the total. Already we have got 5 here. So what should be this question mark square? Question mark square should be ending in 4. Why? If this value ends in 4, 4 plus 5 makes it 9. Question mark square should end in 4. Now when does the square of a number end in 4? Look at this. This is a square. Something should come in place of question mark. That's what we are required to find out. Now what square will end in 4? Either the number should end in 2 or the number should end in 8. 2 square 4, 8 square 64, ending in 4, 12 square 144, 18 square 324, and so on, right? So either the number should end in 8 or should end in 2 or 8. Those are the possible answers. Answers should end in 8 or in 2. Look at the options. 75, not possible. 77, not possible. Not possible. Not possible. 100%, fifth option, none of this is the correct answer, which I'm sure most of you have followed. You've got the right answer without doing the complete calculation. So this is how unit place method will help you out. Get to the point. I know that the answer should end in 4. 75 square doesn't end in 4. 77 square doesn't end in 4. 79 square doesn't end in 4. 81 square doesn't end in 4. What ends in 4 here should be the fifth option. Let's take one more quick question on this one. $398 into question mark into 7 is equal to 47,362. The options are 15, 13, 17, 19, none. 398 into question mark into 7 equals to 47,362. We are required to find out what comes in place of question mark. I will give you 10 seconds. I'm sure all of you will get the right answer. Your time starts now. Right. So I believe all of you have got the right answer. What do? Go for unit space. The right hand side ends in 2. It's obvious that left hand side should also end in 2, right? But which has got a question mark there. So let's check. How is it possible? One number ends in 8, the other number ends in 7. When you multiply, the answer will end in 6. 8 into 7, 56. So the answer will end in 6. That means the product of 398 and 7 is going to end in 6. 6 into question mark should be equal to what? Ends in 2 here. Yes or no? This side ends in 2. Product of these two ends in 6 multiplied with question mark. Now, what should come in place of question mark so that the units place of that number when multiplied by the units place 6 here will result in 2. That's what we need to verify. Substitute the options one by one. Let's take 15. Assume 15 is the correct answer. If 15 comes here, what is the units place? 5. 5 into 6 is what? It ends in 0. What we want here? 2. Not possible. 3 into 6, 18. What we have here is 2. Not possible. 6 into 7, units place here. 6 into 7, 42. 42 ends in 2. 6 into 7. That means this number when multiplied by 17 will result in an answer which ends in 2. Here also we have something ending in 2. So possible. This is possible. We cannot say that that's the right answer at this point of time, but possible. 90. 6 into 9, 54 ends in 4. What we want ends in 2. What are the possible answers? Either 17 or fifth option, none of these. Fifth option, none of these. Again, the same question arises. Which is correct? We have no idea. What we only know is first option, second option, third option are wrong. Now I would like to repeat the same point. It depends on you. If you're ready to take a chance, mark 17. Or if you don't want to take a risk here, if you want the complete solution, if you want the proper answer, right answer, go for the complete solution. Let me tell you what I do in this situation. I will say 17 is the right answer. I will not worry about fifth option on this. And I'm not doing any calculation here. I'm just trying to, apply the time management logic here. Look at this. If at all I do the complete calculation, how much time do you think will it take? It would easily take more than 1 minute. 47,362 should be divided by 398. Then it should be divided by 7. Division generally takes more time, and moreover this kind of division will take much more time. So the point here is, if at all I want to find out what comes in place of question mark following the complete procedure, it's going to take a lot of time, which I don't want to spend. I don't want to spend 2 minutes to get the right answer. I would be happy to lose 0.25 mark. I would be happy to go for that negative marking in 10 seconds rather than scoring 1 mark in 2 minutes or maybe more than that. So that is what you need to understand. In such situations, mark 17 as the answer. You may be wrong. You should be ready to go wrong. You should accept that, yes, there are chances that you'll go wrong, right? But 50-50, 50-50. We are not making blind guess. Again, the same point. First, second, fourth are wrong. Third option or fifth option. If at all you have a different thinking, mark fifth option, because even that may be correct. Who knows? It need not be 17. It can be 27. It can be 37. It can be 47. Mark fifth option. But then try to understand. Solving the whole question here doesn't make any sense. So if at all your idea is to get the right answer always, I would say leave such questions. If at all you don't want to take chance, if you are that candidate who always completes the question, then I would say leave this. There is no point in getting 1 mark in 2 minutes. Either leave it or do it in a smart way. That is unit space method. And if you want to just do some little verification to check whether 17 is possible or not, you can do an approximate calculation. For example, 47,362, can I take it as 48,000 approximately? 48,000, yes or no? 48,000. 398 is 400. 48,000 divided by 400. 48,000 divided by 400. How much is that? 120. 48,000 by 400, 120. 120 by 7. 120 by 7 is approximately 70. 70 into 18, yes or no? 7 into 17. How much is that? 7 into 17. What is 7 into 17? 190. 70 plus 49, 190. So the idea here is, even if we go for an approximate calculation, it clearly suggests that it should be around that 17, 18, or between 10 to 20. It cannot be 27. It cannot be 37, right? It should end with 7, and it should be in the range of 10 to 20. So obvious answer is 17 here. So I can say 17 is the correct answer. So try and understand. There will be certain questions in the exam where you have to take a chance, and you have to decide what those questions are going to be. Are you able to follow? And I don't say that blindly for every question do this. No. There are certain questions where you have to go for complete calculation. No other logic works. But then, in such cases, try to avoid wastage of time by doing the complete calculation, right? Simply apply unit space method or digital route, which I will be explaining next, and try to get the right answer. Try to get the most probable right answer, I would say, right? Instead of spending too much time and getting the right answer, exact answer, right? Let's take One more question. Now I'm going to give you a very typical question which most of the students would say we should leave it. As I've mentioned, remember friends, if you are not able to get the right answer in less than 1 minute, the best way to solve such a question is leave it. Simplifications or any other topic, if at all you find that no, in 1 minute I will not be able to get that 1 mark, the best way to solve such questions is leave it. Especially when it comes to topics like simplifications or approximations, number series, coding and decoding, because complete calculation or find the logic in coding and decoding would take how much time? You never know, right? It all depends on your speed. It all depends on how you think at that point of time. So there is one very smart solution for some questions. What is that? Leave it. Leaving a question does not mean that you have failed. It just means that you're respecting the question. Yes or no? Like batsman leave the ball, right? He's leaving the ball does not mean that he can't hit it. He doesn't want to, take that chance there, right? He's respecting the ball. That's a good ball. He's respecting the bowler. Right? He only waits for bad balls to hit, right? We also do the same thing. Look for easier questions. Complicated ones, which would take more than 1 minute, just leave them. Now I'll give you one question for which what you need to think is, do you want to solve or not, right? More than giving me the answer, the first thing that you have to decide is, should I solve it or not? Should I leave it or solve it? What will be the best solution? So 18,696 divided by 20,853 multiplied by 11,916 divided by 28,728 equals to what? Options are 181 by 331, 164 by 441, 155 by 246, 161 by 241, and the fifth option is none of this. Remember, units place method does not work in case of division, which is as in the given question here, right? So just think of it. What are you going to do? Do you want to solve it or leave it? I was mentioning that if you feel a particular question is going to take more than 1 minute, the best solution is just skip. I'll give you 1 minute to decide what will you do in such situations, right? Think of it. Is it worth solving or not, right? Can you really get the answer in a smart way? If there's no other smart way of getting the answer, because units place very clearly does not work. You can't say that 6 by 3 will end in 2, 6 by 8 will end in 2, and that cannot be done. It does not work in divisions, right? So 1 minute, think of what you can do. If at all you want to solve it, try to get the answer in that 1 minute. Your time starts now. Five seconds more. And the time is up. So whatever you have decided, to leave it or to solve it or what's your correct answer, that is with you. Let me show you the solution for this one. Ideally, I would say leave. There is no point in touching such question. This is what I get to know from most of the students, right? Most of the students, 95, 98% of the students in my class generally say that it's better to leave after I explain that concept of respecting good question. This is a good question. Do you think solving this question at all will give you the answer in less than 1 minute? No. 5-digit number by 5-digit number, or if you go by multiplication first, 5-digit number has to be multiplied by 5-digit number. If you work on paper, that would easily take about 45 seconds. Another 5-digit multiplication, another 45 seconds, around 2 minutes, 1.5 to 2 minutes gone in just doing the multiplications. And then you have to divide. which would take another 1-2 minutes. 3 to 4 minutes you spend, and then if you look at the options, all are typical: 181 by 331, 164 by 441. So maybe it would take a lot of time. Yes or no? Easily it would take 3-4 minutes. So the ideal decision, if you don't get a smart way of getting the answer, you better leave it. Don't even think of solving such question on paper, right? You are only going to make your life complicated if at all you start solving this on paper. So either you leave it or you do what I'm going to explain you now, right? How much time do you think? 4 minutes? That's what we have understood. Our estimation is that it would take 4 to 5 minutes. But if you are smart, you will get the answer for this question in less than 10 seconds. I repeat, yes, you will get the answer for this question in less than 10 seconds. And when I say less than 10 seconds, it's obvious that we are not going to do paperwork. We are going to apply some smart technique. And I would say there are chances that you may go wrong also, but you will be able to at least eliminate the wrong answer options. So let's look at this. What do we do? Units place method. Now you might be wondering, we very well know that units place does not work when it comes to divisions, but how do we apply it? Just think of it. First, simplify the numerator. 6 into 6. One number ends in 6, the other number ends in 6. Their product will end with 6. Yes or no? So we'll get some 8-digit, 9-digit number ending in 6. Look at the denominators. One number ends in 3, the other number ends in 8. When you multiply, their product will end with 4. Yes. So this will end in 4, right? 3 into 8, 24, and with 4. Equals to what? 6 by 4. Now, when one number ends in 6, the other number ends in 4, the division will end with what? We don't know. We cannot say. Cannot be determined. Insufficient data. Why? Division, we take the number as a whole, right? So you cannot say 6 by 4 will end with 4. 16 by 4, 4. Or 36 by 4, 9. Or 6 by 4 is 1.5. No, those logics does not work here. Division you cannot apply. But friends, if at all you try to balance the unit spaces with the help of options, it must satisfy. For example, look at the first option, 181 by 331. Let's take 181 by 331. If at all this is the answer, division it does not work. But can I cross multiply and check the unit spaces on both the sides? Yes. For example, when you cross multiply, what happens? 6 will be multiplied by 331. That number ending in 6 multiplies with 331, and 181 will get multiplied with 4. And now the unit space have to balance. If at all that is the correct answer. See what happens. 6 into 1. 6 into 1. Cross multiplication, right? We are not checking with division. We are checking with multiplication. So we are taking the denominators to the other side and converting the question to multiplication. That is what is the logic that you need to apply here. So 6 into 1. 6 on the left hand side. 4 into 1. 4. Left hand side ends with 6. Right hand side ends with 4. Is it possible? Not possible. Go for the next option. 164 by 441. 164 by 441. This is ruled out. 6 into 1. 6. 4 into 4. 6. 4 into 4, 16 ends with 6. 6 and 6. Possible. Maybe this is the right answer. Go for next option. 5 by 6. Just look at this part. 5 by 6. So 6 into 6. 6. 4 into 5. 0. Not possible. 6 into 1, 6. 4 into 1, 4. Not possible. Either the answer has to be second option or it has to be fifth option. So what's the smart technique here? Cross multiply. In such cases, you can cross multiply and you can verify the unit spaces there. So you have to understand this. Again, remember, just knowing this, just being able to solve this does not, does not guarantee that you'll be able to solve all the questions in the exam. It all comes with practice. These smart ways will come to you only with practice. So the shortcut for simplifications is practice. The more you practice, the easier it gets. Right? Let's move on to the next question. So something which appears to be complicated. I'm sure most of you said we'll leave it. Most of you thought we'll leave it. Right? Look at this. I'm able to mark a probable answer. Again, fifth option, none of this is there. We cannot argue on that. Fifth option on this, always possible, right? But 1, 3, and 4 are not the answers. Either second option or fifth option. I'm ready to take that chance. When I'm getting the answer in 10 seconds, when I'm getting a probable answer in 10 seconds, for something which takes 4 or 5 minutes, I'll go for it. I'll mark second option. Either +1 or minus 0.25. If you're not comfortable with this, then leave it. Don't think of solving this on paper. Right. Let's move on to the next part now. I'll take just one question on percentage so that you don't find it difficult for doing percentage related. Because again, questions, simplifications based on percentages is what? It all depends on your percentage calculation ability. We have already learned in speed maths how to do percentage related calculations. So we'll just try and apply to one of these questions and see how to get the answers. Look at the question. 15% of 524 minus 2% of 985 plus question mark equals to 20% of 423. Options are 25.9, 27.7, 25.7, and the last option here is 24.9. Fifth option, you know, is obvious, none of this, right? Fifth option, none. So generally, don't try to worry about fifth option, none of this, because in most of the simplifications questions, we generally find fifth option to be none of this. So that's the question there. Now, there's no shortcut. There's no method or technique which can directly give you the answer. Maybe you can apply unit space method, but again, 7 and 7, 9 and 9, there are possible answers. I mean, there are repetitions. So depends. Maybe if answer should end with 6, I can directly mark fifth option, none of this. Right? But here 9 is in 2 places, 7 is in 2 places. So you have to be a little careful. How to get the answer for such questions is all depends on how you perform percentage related calculations. Right? Look at this. 15% of 524. If at all you have the habit of doing percentages this way, 15 by 100 into 524, then 5 3s are 5 20s are, I would say leave it. This is not your cup of coffee, right? Just leave it, move to the next one. You can't be doing percentage related calculations this way. Try to do it mentally. If you are good in that, you'll get the answer in 30 seconds. 15% of 524. 15% is 10% plus 5%. I'll not explain this in detail. It's there in speed maths. It's all in your practice. It's not anything which I have to discuss here, right? 10% plus 5%. 10% is 52.4. 5% will be what? 26.2. So 52.4 plus 26.2, 78.6. This part is 78.6. 2% of 985. 1% is 9.85. 2% will be double. So 9.85. 9 doubles 18. 0.85 doubles 1.7. 18 and 1.7 will be 19.7. 19.7. Negative sign. Plus some question mark will be equal to 20% of 423. 10% is 42.3. 20% has to be double. So 84.6. Yes, this is 84.6. That's it. Now you can do the calculation. 84.6 minus 70. Question mark is on this side only because this is positive. Let's keep it here. Take the other things on the other side. So 84.6 minus 78.6 will be giving you how much? 6 plus 6. And minus 19.7 comes on this side plus 19.7. So 6 plus 19.7, 25.7. That's your answer. So I would simply say it all depends on how you do your calculations, how do your percentage related calculations. Let's now move on to the last part of the session. I would take about 10 minutes to explain this, which is a very, very useful technique. It actually comes from Vedic mathematics, which is called by different names. You can, call it a digital root method or a root digit method and so on, right? So let's understand what is the concept here and let's see how can we apply this to certain questions. That's again like applying unit space method. This is very obvious, but then may not be applicable in all the questions because fifth option is none of this. But if you are ready to take a chance, if you want to go for a probable correct answer, then this will also help you, right? So digital root method, or I would say root digit method. Let's look at this. Root digit method. Now, what is meant by this root digit method, or what is meant by root digit in the first place, right? What do you mean by root digit? Root digit, or some people also call it as a lucky number, lucky digit, lucky number, right? See, generally we find people when they go for the vehicle registration or some house registration or some kind of registration which involves a number, they try to get a number which adds up to a single digit, which is the lucky digit. Are you able to follow? For example, there is a 4-digit number, vehicle number, generally a 4-digit number, right? So they try to get that number where the sum of the digits is either 9 or 6 or 7 based on what is their lucky digit. So that's what basically is known as a root digit. Root digit is a concept where you add all the digits of a number, you keep adding the digits till you get a single digit number. For example, 75. What is the root digit of 75? See, don't confuse this with square root. For example, 64. What is the root digit of 64? Don't say it's 8. No, I'm not asking you the square root. Square root is 8, but root digit is not 8. What do you mean by root digit? Add the digits till you get a single digit number. So 7 plus 5, add the digit. 7 plus 5, 12. Again, 12 is a 2-digit number. I want a single digit. 12. 1 plus 2, 3. So the root digit of 75 is 3. What's the idea? 7 plus 5 gives you 12. 12 again, 1 plus 2 gives you 3. So this is what you need to do till you get a single digit number. I mean, don't have to write on paper. I'm just trying to explain. Likewise, 64. What's the root digit? 6 plus 4, 10. 1 plus 0. 10 is what? 1 plus 0. Root digit is 1. If I give you a number 574321 What's the root digit? 5 plus 7. 5 plus 7, 12, 12 plus 4, 16, 16 plus 3, 19 plus 2, 21 plus 1, 22 plus 8, 31. 31, 3 plus 1, 4. Root digit here is 4. There's another way of calculating root digit. I mean, not another way I should say, but a smarter way of getting a root digit. Remember, as per Vedic mathematics, as per the ancient Indian mathematics, 9 is considered to be the most powerful digit. It's the most powerful number, right? There are reasons behind that. Let me not get into details of that. But understand, while calculating the root digit, if you find any single digit as 9, you can avoid that. Or any 2 digits adding up to 9, you can just avoid that. That is not going to affect your root digit. For example, here, I can leave 9. Even then, the root digit remains 4. Look at this. 5 plus 7, 12. 12 plus 4, 16. 16 plus 3, 19 plus 2, 21. Plus 1, 22. 22. 2 plus 2, 4. So you can avoid all these 9s while finding out root digit. You don't have to include that 9 in calculation of your root digit. Right? Likewise, not just 9. If 2 digits make up 9, you can leave them. For example, in this case, 7 and 2 is 9. 7 plus 2 is 9. Forget them. Forget about them. Take the remaining one. 5 plus 4, 9. 9 plus 3, 12. 12 plus 1, 13. 1 plus 3, 4. It's going to be same. Or 5 and 4 also make up 9. Leave them. 3 plus 1, 4. That's the root digit. Right? For example, now if I ask you, what is the root digit of 169324? Don't add all of them. 6 and 3 is gone, 9 is gone. 2 plus 4, 6, 6 plus 1, 7. The root digit here is 7. So this is what is basically meant by root digit. Now how can we use this? How can we use this root digit method, or what's the root digit method which can be used for doing questions on simplifications? So let's look at it. I'll just take 1 or 2 examples, but before that let me explain you what is the concept here. For example, 126 plus, let's take some number, 321 equals to what? Add this. 126 plus 321, 120, 320, 440, 6 and 1, 7, 447. Yes or no? 6 plus 1, 7, 2 plus 2, 4, 1 plus 3, 4. Addition there. So that's the equation balance. Now, as per Vedic mathematics, or as per the digital root digit concept, let's find out the root digits of these numbers first. What is the root digit of 126? 1 plus 2, 3, 3 plus 6, 9. This is 9. What is the root digit of 321? 3 plus 2, 5, 5 plus 1, 6. Now add, because here it is addition, we are adding 9 plus 6, 15. 15, what is the root digit? 6. Or as I mentioned, don't have to worry about 9 there. Wherever you find 9, just leave. Root digit of the left hand side is equal to what? 6. Now, as per this concept, root digit also will get balanced on both the sides. Not just the sum, not just the equation, but the root digits are always balanced in any kind of arithmetic equation there. Let's check. 447. Find out the root digit. 4 plus 4, 8, 8 plus 7, 15, 15, 1 plus 5, 6. Is it balanced? Yes, it's balanced. This is the concept. Now I don't have to tell you how can we use this. 126 plus question mark equals to 447. Instead of doing the calculation, check whether the root digit is balanced or not. Which option balances the root digit? You get the answer. Right? Same thing is applicable for multiplication as well. Multiplication, addition, subtraction, division. But again, division you have to be careful. Remember, units place method is not applicable for division. But in a smart way, we have used it in the previous question, that 18,000 something and 20,000 something, right? Verification from units place. So same thing can be done for digital root or root digit method as well, right? I like to explain you about multiplication. For example, let's say 32 into what? 32 into 19, let's say, equals to what? What is 32 into 19? 640 minus 32. That is equal to 608. Multiplication. Root digit has to balance. Yes or no? Root digit has to balance here. So 32 into 19 equals to 608. Let's check. What is the root digit of 32? 5. What is the root digit of 19? 1. 5 into, again, remember, same operation has to be taken. 5 into 1. 5 into 1 is 5. So root digit of the left hand side is 5. Root digit of the right hand side should also be 5. Check. 6 plus 0, 6. 6 plus 8, 14. 14 was the root digit. 1 plus 4, 5. Is it balanced or not? Yes. So that's the concept of root digit. And this is what we can use while answering certain questions. Well, I would say, if you ask me which is better, unit digit method is better or root digit is method, my simple and clear answer here is unit digit method. Because root digit, though it appears to be interesting, it appears to be, very nice, but then it takes more time compared to unit digit. In unit digit, we just take the last digit, but root digit you have to add and keep adding those numbers till you get the single digit, which will take more time. So that is the reason, if at all you have to decide which one to apply, first apply unit digit method. If that fails, try root digit. And again, let me tell you, even this may fail. Fail as in you may not be able to get the right answer because 2-3 options may be possible, right? Unit digit method, 2-3 options are possible. Here also, when you verify from the options, first option root digit may be 5, second may be 5, third may be 5, fourth may be 5. You may not be able to apply. You may not be able to mark the answer. So it all depends on what kind of questions are given. Let's just take 1 or 2 examples on this, and we'll close the session after that. For example, and the options are 196.5, 186.5, 196.75, 200.5, 136.5. So look at the question: 1097.63 plus 2197.36 minus 2607.24 divided by 3.5 equals to what? Options are 196.5, 186.5, 196.75, 200.5, 136.5. So how do we apply root digit method in this case, right? I'll just give you 20 seconds. Think of it, right? Try to get the answer. We'll see the solution after this. All right, so I just hope, friends, that all of you have got the right answer. Let's look at the solution for this one. Now you know how to answer this. In fact, these were some of the questions that we have discussed in the beginning. But then this involves a division here, right? So what do? You can go for the complete solution, which would take about 1 minute or maybe a little more than that. But let's check how root digit method can help us get the answer, because all the options are there without fifth option being none of this. So let's just think of it. What do we do here? Find out the root digit of each number. Forget about the decimals. Remember, decimals you don't have to worry about when it comes to root digit. So find out the root digit. 6 and 3 anyway gets cancelled, 9 gets cancelled. 1 plus 0 plus 7, 8. So this is 8, this number. 9 here is getting cancelled, 2 and 7 gets cancelled, 3, 6 gets cancelled. What is left out? 1. So root digit of first term is 8, second term is 1. Third one here. 7 and 2 gets cancelled. 2 plus 6 is what? 8, 8 plus 4, 12. 12 means 12 again is what? 1 plus 2, 3. So for this it is 3. Divided by 3.5 equals to what? Right? Now try to look at this part now. 8 plus 1 minus 3. What is 8 plus 1? 8 plus 1, 9. 9 minus 3, 6. Yes or no? 8 plus 1 minus 3. 9 minus 3 is 6. So 6 is the root digit divided by 3.5. That root digit is nothing but again 8. 6 by. Don't try to simplify. Don't say 6 by 8 is 3 by 4. Don't simplify root digit in that manner, right? 6 by root digit of 8 should be equal to what? Question marks. What we'll try to do here is, you know that if you take this 8 on the other side, question mark into it. So one root digit, left hand side is ending in a root digit of 6, should be equal to question mark into root digit 8. Substitute the options. That root digit of options when multiplied by 8, the root digit. If that happens, maybe that is the right answer. Again, we cannot say that that itself is the correct answer, because there are many numbers which can give you root digit of 6 when multiplied by 8. Right? But then elimination of answers will be possible. Let's look at this one. 196.5. What is the root digit? 1 and 6, 7, 7 and 5, 12. 12 is what? 3. Yes or no? 6 and 5, 11 plus 1, 12. 12 is 3. 3. Now, if this is the correct answer at all, if that is the correct answer, what happens? Question mark will be substituted by the root digit of 3. 3 into 8 is how much? 24. 24 root digit is what? 2 plus 4, 6. Balanced or not? 6 and 6. This is giving 6. So maybe 196.5 is correct. But is it really correct or not? Depends on the remaining options. If this option also gives me a root digit of 6 when multiplied by 8, gone. Right? If at all these are ruled out, it will be easy for us. So that's what I told you. Root digit appears to be easy, but actually it's complicated to apply because more than one option may satisfy. Right? So first prefer unit space method, then go for root digit method. Let's look at this one. Find out the root digit. So now it's obvious that root digit has to be 3. Only when root digit is 3, 8 into 3, 24, 2 plus 4, 6 will be the balance, right? 186.5. What's the root digit? 1 and 8, 9. 6 and 5 is 11. 11 will give you 2. If you take 2, what happens? 8 into 2. Are you able to follow? Instead of root digit 3, you will have 2 here. So 8 into 2, 16. 16 is what? 1 plus 6, 7. Not balanced. So this is ruled out. 196.75. 9 is gone. 6 and 1, 7. 7 and 7, 14. 14 and 5, 19. 1 plus 9, 20. 20 is what? Root digit is 2. If this 2 does not satisfy, this 2 will also not satisfy. Look at next one. 200.5. 2 plus 5, 7. 8 into 7, 56. Yes or no? 200.5. So 200.5, 7. 7 into 8, 56. 7 into 8, 56. Root digit is 7. 8 into 7, 56. 56. 5 plus 6. Understand? Here we are getting 56. 5 plus 6, 11. 11. Again, 1 plus 1, 2. What we want is 6. This is also ruled out. In the last option, 136.5. 3 and 6 anyway is gone because it's making 9. 1 plus 5 is 6. 6 into 8, 48. 6 into 8, 48 means what? 4 plus 8, 12. 1 plus 2, 3. What we want is 6. Even this is ruled out. Correct answer has to be first option, 196.5, because that's the only option which satisfies the root digit concept here. That's the correct answer. But then, see, it takes time. Again, we are fortunate, we are lucky that only one option satisfies. If more than one option satisfies, then again, you'll have to go for an approximate calculation to check which of the 2 is correct or which of the 3 is correct. If all the options satisfies, gone. You don't have any lead about the right answer. You have to do the complete question. You have to do the complete solution. So it all depends on what kind of questions are used. But then, useful technique. Useful technique, if you can use it smartly, definitely it will help you in the exam, right? You can't be applying this to every question because it is lengthy. If you ask me, this is really lengthy. But better than the actual calculation. Just one question, the last question of today's session, and we'll close. Let me just pick up one more question so that I can explain you this root digit concept again. For example, 43 squared plus 841 equals to question mark squared plus 1465. The options are 15, 65, 45, 35, 25. 15, 65, 45, 35, 25. We are required to find out what comes in place of question mark, right? Look at this. This is question mark square. So 43 square plus 841 equals to question mark square plus 1465. What do you do? 43 square. That means what? 43 into 43. Yes or no? This part is 43 into 43. We are applying root digit directly. I'm just telling you the root digit method here, application of root digit method. So 43 into 43. What's the root digit of 43? 7. 7 into 7, 49. 49 root digit will be 4 because 9 gets eliminated. So here the root digit of first part is 4. Plus root digit of 841. 8 and 1 gets cancelled. 4 and 4 is left out. So 4 plus 4. What is the overall root digit of left hand side? It is 8. Remember, generally what I write inside the circle is root digit. That's just to understand that this is root digit. Otherwise we get confused whether it is root digit or some other number, right? So that's only an identification part here. So 4 plus 4, 8. Root digit of the left hand side is 8. Now comes the remaining part. Let's find out the root digit of this part. 1, 4, 6, 5 and 4 is gone. This is 7. Yes or no? 1 plus 6 is 7. So root digit here is 7. Already the root digit here is 8. Complete left hand side 8 should be equal to question mark square plus root digit of 7. Now because this is plus, I know that here the root digit should be 1. For question mark square, the root digit has to be 1. Only then it is balanced, right? 8, 1 plus 7 will give you 8. 1 plus 7 will give you. So question mark square should be 1. Check from the options. Question mark square. Remember, what is the root digit of 15? 6. 6 square. This is question mark square. 6 square. 6 into 6, 36. 3 plus 6, 9. No, does not balance because I want 1. Ruled out. What's the root digit of 65? 6 plus 5, 11. 1 plus 1, 2. 2. 2 square, 4. Root digit does not, not balanced. What's the root digit of 45? 9. Yes or no? 9. 9 square, 81. 9 with any kind of multiplication will always give you root digit of 9. 9 square, 81. 8 plus 1, 9. Ruled out because I am looking for 1. 35. What is the root digit? 8. 8. 8 squared. 8 squared, 64. 6 plus 4, 10. 1 plus 0, 1. Maybe possible because this is giving me a root digit of 1 when I use square. As such, 35 is giving me 8, root digit of 8, but when I square it, I get 1. So possible, maybe possible. If this does not satisfy, I have the right answer. 25, 2 plus 5, 7. 7 squared, 49. 49 root digit is what? 4. Not balanced. So the correct answer is 35. But then understand, I would say it would be better if you solve this question using the regular procedure than by going unit space. Than by using root digit method, because lucky again that it is satisfied. Otherwise, you may not be able to mark the answer. Doesn't take time. 43 square will be how much? 50 minus 7. Sorry, 43 square, 50 minus 7 whole square. So 1849. You know how to find out square of a number much faster without writing anything on paper. 1849 plus 841. So 1849 plus 841 will be 2690. 2690 equals to question mark square plus 1465. 1465 if you subtract from 2690, it will give you how much? 1225. 1225 is what square? 35 square. So if you are smart in calculations, if you have followed the speed maths concepts clearly, you will be able to answer the same question much faster, right? But just the application of root digit method is what I have explained here through this example. So that's how you can apply some of these techniques in answering the questions from simplifications. I would like to close the session now. I hope all of you have enjoyed this. Make sure that you practice more and more on these questions of simplifications, because the weightage is quite high. As I've mentioned, 10 to 15 marks you get from this particular topic in the bank exams, especially in exams like SBI clerks, right? Remember, practice is the key. Knowing the method will not help you. You should be able to apply that. And when will you be able to apply that? Only when you practice, practice, and practice. Thank you. I hope all of you have enjoyed this session. Please share your valuable feedback. If you have any queries or any doubts regarding simplifications or any other question, you can write it to faculty@bankerschoice.in, right? I'll try to give a timely response to email. And if at all, if I find the question to be complicated, that I cannot explain it through email, I'll explain in the next live doubts clarification session of quant and reasoning respectively, right? So if you have any questions, please write it to faculty@bankerschoice.in. Thank you all for joining us. Keep practicing. See you in the next session. And the next session tomorrow is going to be on approximations and number series. So again, number series is not in our hands. It's not in our control, right? Infinite logics, you have to think divergently to get the answer. But what we'll really look at is tomorrow. What we'll really look at tomorrow is on the approximation techniques, right? How do you get an approximate answer, a better approximate answer much faster? So see you in the next session. Keep practicing till then. Thank you all for joining us.